So, hello everyone. Today we are going to discuss about the Gauss divergence theorem and its applications. Okay, so Gauss divergence theorem and its applications. So first, let us see the what is a Gauss divergence theorem statement. Okay, so this is the statement will be there. The double integration of f dot n into ds equal to the triple integration of divergence of f into dv. So you should remember these things. The double integration of f dot n into ds equal to the triple integration of divergence of f into dv. Okay, so this is the things. Okay, so first let's see the depending on that formulas, Gauss divergence theorems, and we are solving that how to find the surface area. Okay, see here the first problem. So evaluate f dot n into ds, where f equal to axi plus byj plus czk, and s is the surface of the sphere, x square plus y square plus z square equal to 1. So just now we discussed what is that f dot n into ds equal to, this is nothing to what is the divergence of f into dv. So now we are going to find out the divergence of f. So what is the divergence of f? Dou by dou x of ax and dou by dou f of by and dou by dou z of cz. So this is f1, okay, and this is the f2, and this is the f3. Okay, so now the divergence of f equal to dou by dou x of f1 means ax, dou by dou f of by, f2 dou by dou z of cz. So dou by dou x of ax is a, and dou by dou f of by is b, and dou by dou z of cz is z. So now we have to substitute there. So the triple integration into dv. So the triple integration into dv is v. So this given it is a sphere. So the volume of the sphere is what is it? 4 by 3 pi r cube. Okay. So 4 by 3 pi r cube. So when it is 4 by 3 pi r cube, that is become 4 by 3 pi 1 square, that is become 4 by 3. Okay. Now you got it now. This is it. Evaluate the f got down into ds into x square plus y square plus z square equal to 1. Okay. Now, same we have to apply that theorem, and we need to find out, evaluate the things. So next problem, apply the divergence theorem and evaluate the double integration of x plus y plus z into dy dz and y plus z into dz dx and x plus y into dx dy. So this is f1 and this is f2 and this is f3. Okay. So using that Gauss divergence theorem, so we have to evaluate mm, that f1 into dy dz and f2 into dz dx and f3 into ds dx is nothing to what is it? The triple integration of divergence of f into dv. Okay. Now what is the dv? So dv equal to dx, dy and dz. Okay, now we have to substitute here. So divergence of f. So divergence of f means dou by dou x of into f1 and dou by dou f of into f2. So dou by dou x of x plus z, dou by dou f of y plus z and x plus y. So that's we are getting 1 plus 0. That's we are getting 2v. So this is a sphere, no? So we know that that sphere value is 4 by 3 pi r cube. So that's we are getting 64 pi by. That's we are getting this is the 2 square. So 4 we can write this is the 2 square. So that radius r equal to what is it? 2. So r equal to 2. Then we are getting 64 pi by 3. Once see the example. Okay. Now let's see the one more example. See here, so evaluate the double integration of x square of x into dy dz and y into dx dz and plus z into dx dy, where s is the surface of the cylinder, x square plus y square equal to a square and bounded by the plane z equal to 0 and z equal to b. Okay. So by the Cartesian form of the divergence theorem, so then we are getting that just now we discuss about no the double integration of f dot n into ds equal to what is that? That divergence of the triple integration of divergence of f into dv. Okay. So now we need to find this is the divergence of f. So the divergence of f means dou by dou x of f1. So this is the f1 and dou by dou f of f2 and dou by dou z of f3. Okay. So this is that. Okay. Now we have to do the triple integration. So dv is nothing to what is that dx, dy, dz. So just they given what is that here, see, z equal to 0 to b. That's finish. So we need the y limits. So we need the y limits means x square plus y square equal to a square. Okay. So from here that y square equal to, so y square equal to we can write what is that under root of a square minus x square. Hmm? So y equal to that's become what is that plus or minus under root of a square minus x square. Okay. Now this is so for the x limits. So we have to substitute here. Hello. ఎంటర్ అయిన తర్వాత రైట్ తీసుకోండి కోరు కాదు పక్కన ఆ, ఓకే. ఓకే. So we need to find that x limits. So for the x limits, we have to substitute that y equal to 0. So if you are substituting that y equal to 0, then we are getting x square equal to a square. Okay. So from there, we are getting x equal to plus or minus a. Okay. So these are the x limits. And these are the y limits and z limits. They given that. Okay. So next. Application. Okay, so this is the, so we have the x limits and we have the y limits and we have the z limits. So initially first we are doing with the integration with the y. So that 1 into dy is y. So that y we are writing and apply the limits under root of a square minus x square and minus under root of a square minus x square. Now we have to substitute in place of upper limit and lower limit, and we are getting 2x square into under root of a square minus x square dx dz. So 2 right outside and x square under root of a square minus x square dx. Next, now we have to do the integration with dz. Okay. So that integration of 1 into dz. So integration of 1 into dz is become the z. So z, z. Okay. So 1 into dz. So that is become to z. So now apply the limits, z limits are 0 to b. So when you are applying the z limit 0 to b, then we are getting b minus 0. So that is nothing to b. So b right outside. So that's we are getting 10b, and integration of x equal to minus a to a and x square into under root of a square minus x square into dx. Okay. So this is the thing. So now from here, so we have to integration of this part. So to do the integration of that, we have to go into the simply method to solve these equations, solve the integration. So the simple methods, just we have to substitute that x equal to a sin theta. So when you are taking that x equal to a sin theta, then the dx is become. So the dx is become a cos theta and d theta. Okay, so dx equal to a cos theta d theta. Now we have to substitute x equal to a sin theta. So that is become a square sin square theta and under root of a square minus a square sin square theta, and dx is become a cos theta d theta. So sin square theta and under root of 1 minus sin square theta is nothing to cos theta. So already here cos theta is there, no, that is become cos square theta. And next things. So, and multiply and divided by 4 here. So 4 division and 4 multiply. So that is become, this is 4 sin square theta cos square theta. 4 sin square theta cos square theta, that we can write 2 sin theta into cos theta whole square. So that is become 2 sin theta cos theta, that we can write, what is that? Sin 2 theta whole square. Sin 2 theta whole square is nothing to, what is that? Sin square 2 theta. So sin square theta by 4. Okay, now this is, we are getting this sin square 2 theta by 4 into d theta. So sin square theta is nothing to 1 minus cos 4 theta by 2. Okay, and here 2 will be right outside. A power of 4 by 4. 1 into d theta is theta, and cos 4 theta is sin 4 theta by 4. Okay, and apply the limit 0 to pi by 2. Then we are getting, in place of theta pi by 2 and 0, that is become a power of 4 5 by 8. Now this is that, then we have to substitute this value here. Okay, this is the integration value, no? So 10b into this part. So then we are getting 5a power of 4b by 5 4. Okay, so this is the simplification part, you see. Now let's see the next problem. So this is the one different problem is there. So that evaluate the double integration of 2x square plus 3y square plus 5z square into ds, and over the sphere x square plus y square plus z square equal to 1. Okay. Then f dot n into ds, by the divergence theorem, f dot n into ds equal to divergence of f into dv. So this value is going to that f dot n. So from that f dot n, so we need to find f. From there, we need to find what is that divergence of. So f dot n into f, and from there, divergence of f. Okay. Then we need to find that. So f dot n. So first we need to find f dot n from their f, no. So they were given the surface, this is no. So this is the surface of the sphere. So that perpendicular to that surface is, what is that? Nabla pi. So this is. grade pi. This is we can say that grade pi. So how we can find that grade pi means previous studies we find out that no I into dou by dou x plus j into dou by dou y plus k into dou by dou z. Okay. So grade pi. So from that the grade pi is under root of 4x square plus 4y square plus 4z square. So let's take 4 is common and x square plus y square plus z square, that is 1. So that's we are getting 2. So that unit normal to the surface is what is that? That grade pi by the norm of gate pi. So we are getting that grade pi by norm of gate pi. This is the things. So this is, so but they given f dot n. So f dot n means this is equal to 2x square plus 3y square plus 5z square. So f dot this is 2x square plus 3y square plus 5z square. So if we are comparing that things and we are getting what is that 2xi plus 3yj plus 5z square. See from that f dot n, so we are finding that f. So that f equal to 2xi plus 3yj plus 5zk. Now that grade f, so divergence of f is become, so dou by dou x into 2x and dou by dou y into 3y and dou by dou z into 5z. So that is become 2 plus 3 plus 5. So 2 plus 3 plus 5. So that equal to that is become 10. Okay. So this is grade f. So this is f dot n into ds. So 10 into dv. So v means the volume. The volume of a sphere is what is that? 4 by 3 pi r. So this is that 4 by 3 pi r cube. So that finally we are getting what is that? 45 by 3. Okay. So this is the things. Now let's see here that verify the divergence theorem over the rectangle parallelogram. So this is x is in between 0 to a and y is in between 0 to b and z is in between 0 to c. So we have to verify the Gauss divergence theorem now. So first we have to find that what is the Gauss divergence theorem. So f dot n into ds equal to that triple integration of divergence of f into dv. So first they given that f no. So they given that f equal x square minus yz into y square into zx. Then grade f is dou by dou x, dou by dou y, and dou by dou z. And we are getting 2x plus 2y plus 2z and 2 into x plus y plus z. So now the divergence of uh, dv equal to dx dy dz. So initially first we are doing that integration with respect to x. So that's we are getting x square by 2 xy plus xz and apply the limits 0 to a and dy dz. Next, when applying that limits, upper limit and lower limit, and we are getting a square by 2 ay az and dy dz. Now we have to do the integration with y. Then we are getting a square by 2 into y and a y square by 2 and az y. And apply the y limits 0 to b. So next, z. So when you are doing the integration with the z, then a square b into z by 2 and ab square by 2 and ab z square by 2. So that is become ABC into A plus B plus C. Now let's see here that RHS part. So we need to find F dot N into DX. So for the face of OAFC, so this is for the face of OAFC. So we need to find F dot N into DS. So for that OAFC, that y equal 0 and n equal to minus j. So f, then we are getting that minus y square z into x dx dy. Why? Because that y equal to 0, no? So in OAFC means that we are getting xz plane. So in that xz plane and we are getting these things. Now come to DGB. So in the DEGB that y equal to b, then dy is become also 0. Why? Because y equal to b na, then dy is become 0. Why? Because the constant derivation is become what is that? 0. So dy is become to 0. So then we are getting these things. Okay. And next OCDB. So x equal 0 and n equal to minus I. So we are getting this thing, f dot n into ds. Next AF is, so x equal to a and n equal to I. So all the phases we are find out that. So we are getting this ABC into A plus B plus C. So therefore, that by the Gauss divergence theorem, so it has verified. So this is the verify the Gauss divergence theorem. Okay. Is there any dots? Let's see some previous problems about the Stokes theorem also. Today we are going to do Stokes theorems and its applications. So this is a Stokes theorem. F dot dr into curl F dot n into ds. And the Gauss theorem is F dot n into ds equal to divergence of F into d. So based on this is also we are doing some problems. See here. So evaluate del of F into ds. So this is a stroke theorem. Hmm.